This is on section 3.2, how well the line fits the data for S and R squared. So what S and R squared stand for to begin with, S is going to be the standard deviation for the residuals, and the R squared is going to be the coefficient of determination. So slightly different, but we're continuing on from chapter 3 where we start the fall semester. So I do recommend that you do read these pages, these recommended pages here. And if you want to pause the video now and go ahead and read that, you can. But to get on into this, so if you remember a residual from fall semester, the residual was the difference between the actual and predicted. So if you remember, we did the actual minus the predicted, and that gave you the residual. And we were using the least squares regression line. So you can get all of those at once from a list. Like, you don't have to do them each by hand. If you have your data typed into L1 and L2, then you go up to L3, or go up and make sure L3 is highlighted, second stat, number 7, resid, and then enter. And so now list 3 will contain all of your residuals. So the standard deviation of residuals, it measures how good your predictions will be using a linear model for all the data. And basically what it is a typical prediction error. So when you predict a data point from your prediction equation or least squares regression line, it will tell you what the standard deviation tells you is typically how much it could be off by. And so here's the formula, which all this means is the sum of the residuals squared divided by n minus 2, where n is your total number of data points. So if you have 10 data points, you would divide here by 8. And then, of course, you take the square root of that. Now, right now, there is not a way for us to do this entire thing in our calculator. So you do need to make sure that you memorize this formula and you know how to calculate it. Now, you can get the sum of the residuals squared. Oh, sorry about that. You can get the sum of the residuals squared if you just go to Stat and Calc, do your 1var stats, and make sure that L3 is listed for that. And that will give you that number. And you're looking beside of this symbol right here. So that's going to give you this top number. That's going to give you the long part. So you're not having to add up all of your residuals and square them. And then you just divide by 2 less than the data that you have, and then take the square root of that. Now, this is not, you cannot use the standard deviation in your calculator. It is not the same for residuals. There is a small difference in the two formulas. So for the residuals, we do n minus 2. And for standard deviation of data, you're just doing n minus 1. And briefly, I'll talk about that just a little bit here. But basically, one way to think about it, if you only have 2 points, you can calculate a least squares regression line. But there's no way to estimate variability, because if there's 2 points, there's no variability from those 2 points. So that's why we do n minus 2 to use that in this particular formula. But you really don't have to worry about that. But just know that standard deviation and standard deviation of residuals, there is a difference. And basically right here is your difference in it. Okay, so if we go back to the tapping on the cans example, so think way back in the fall, it was the example where we referred to 2 people took 40 cans and they shook them all up and they tapped on the top of it for a certain amount of time before they opened it.